Welcome back to Universal Things YouTube channel. Tonight, imagine this. You wake up, check your phone, and every news headline says the same chilling words. The Antarctic ice shelf broke overnight. No warning. No time. Just an event so huge it shifts the entire planet's future in a single night. The Antarctic ice shelf isn't just ice. It's a colossal, frozen barrier holding back unimaginable amounts of ancient glaciers. If it suddenly fractured, the world wouldn't just notice, it would be shaken. This is the scenario scientists fear most because it triggers a chain reaction we cannot stop. Within hours of the collapse, satellites would detect massive icebergs drifting into the Southern Ocean. Some would be larger than entire American states. The global scientific community would scramble, trying to calculate how fast sea levels could rise and how severe the consequences would be. The first major impact would be sea level acceleration. When shelves break, glaciers slide faster into the ocean, like removing a giant stopper from a bottle. Suddenly, trillions of tons of land ice begin migrating toward open water, no longer held back by the frozen shield. Coastal cities would experience the earliest warnings. Tides become unusually high. Flood maps that once predicted danger in decades now shrink to predictions for months or even weeks. Scientists warn emergency managers across the U.S. eastern seaboard, prepare immediately. In Miami, streets that already struggle with king tides would vanish under permanent water. New York would face swelling rivers pushing against seawalls. Louisiana's coastal wetlands, already thin, would slip beneath rising waves. The collapse becomes a national emergency. But the ocean isn't the only thing responding. The global temperature balance begins shifting. The brilliant white ice that once reflected sunlight is gone, replaced by darker ocean water absorbing heat. Earth warms faster, creating a runaway effect scientists have warned about for years. Storm systems change rapidly. Warmer oceans fuel massive hurricanes. The U.S. could see stronger Category 5 storms forming more frequently, especially along the Gulf and Atlantic coasts. The air becomes more energized, unpredictable, and dangerous. Meanwhile, the ocean currents begin to behave differently. The cold meltwater pours into the seas, disrupting the conveyor systems that move heat around the world. This could weaken the Gulf Stream, bringing colder winters to Europe and chaotic weather patterns to America. In the southern hemisphere, marine life faces chaos. Penguins lose breeding grounds, seals struggle to find ice to rest on. Even tiny krill foundation of the Antarctic food chain decline sharply, threatening whales and countless other species that depend on them. Fishing industries worldwide feel the shockwave. Changes in ocean temperature push species north or south, away from traditional regions. Tuna, salmon, cod, commercial staples begin migrating unpredictably. Food prices climb as global supply chains stretch thin. Back on land, governments discuss relocation strategies. Low-lying nations from the Pacific to the Caribbean plead for emergency intervention. Rising seas make entire islands uninhabitable. Conversations about climate refugees turn into urgent reality. The U.S. begins evaluating its own vulnerable zones. Cities like Charleston, Norfolk, and San Diego face long-term inundation risks. Engineers race to elevate infrastructure, build seawalls, and redesign drainage systems. The cost reaches trillions. But the collapse brings another danger: freshwater disruption. As massive volumes of meltwater enter the ocean, salinity changes. This affects weather, ocean life, and even global rainfall patterns. Regions could experience intense droughts, while others drown in relentless storms. As panic spreads, scientists explain the deeper truth. The collapse didn't cause climate change, it accelerated what was already happening. The event becomes a turning point, a moment where humanity must choose between denial and transformation. Across the U.S., citizens begin asking tough questions. How fast can we adapt? Which cities can be protected? Which must eventually be abandoned? What technologies must we develop to survive a climate future arriving years earlier than expected? Meanwhile, world powers gather in emergency conferences. For the first time, climate policy becomes the top priority. Nations debate greenhouse gas cuts, carbon capture technology, and geoengineering ideas once considered too extreme to attempt. Scientists propose a global action map, rapid emission reductions, advanced cooling technologies, ice sheet reinforcement experiments, and ocean reflectivity projects. Some ideas sound like science fiction, but the alternative is a world reshaped beyond recognition. The collapse becomes a lesson written in ice, a reminder of how fragile Earth's systems truly are. People everywhere rethink their relationship with the planet, realizing that every action carries weight and every delay has consequences. So imagine looking back years later and remembering the night the Antarctic ice shelf broke. A moment when humanity faced its own reflection. What would you feel? Fear, awe, responsibility, and more importantly, what choices will shape the world you leave behind?